All right, we're going to continue with our series of solving quadratic equations, this time again by completing the square. Here we're going to focus on a situation where a is not equal to 1. So what we must do to begin, looking at this example, negative 4x squared minus 5x is equal to negative 3. Our goal is first to make it into a situation that is more accessible to us, that is more familiar to us. So we are going to divide all the equation, the entire equation, by that a value, negative 4. And what that will do is it ends up creating a situation that is familiar to us. It resembles the previous examples. We will have some fractions, and that's not a big deal. It's stuff that we can handle, and if we can't, our trusty calculators can. So let's start with this first example, and then we'll work on and do another one that's maybe a little bit more complicated. So first, let's divide this equation by negative 4. We've divided both sides of the equation by negative 4. This is our resulting equation. And now we're going to continue by completing the square as we did in the previous video. We need to take the b value, divide it by 2, and square it, adding that quantity to both sides. Half of 5/4 is 5/8. Essentially, we just multiply the denominator by 2. And we'll add the square of b divided by 2 on both sides. All right. Using our calculator, we'll find out that 3/4 plus 5/8 squared gives us 73/64. And I should double check that just to make sure. 3 divided by 4 plus 5 divided by 8 squared gives us a fraction that we can write as an improper fraction, 73/64. Okay, good. I'm just making sure I did my math correctly. Now to continue this, we'll take the square root on both sides, keeping in mind that we are solving an equation. So when we take square roots, we have a positive and a negative root over here. All right. This radical, we can simplify a little bit. Basically, the square root of 73 is just the square root of 73, but the square root of 64 we know is 8. And now we will subtract 5/8 from both sides. These fractions have a common denominator, and so we can combine them. And this gives us both solutions. Negative 5 plus the square root of 73 divided by 8, and negative 5 minus the square root of 73 divided by 8. For our second example, things are going to get a little bit tricky, and that's going to be all right. We'll be able to handle this. We will end up with a complex solution, or with complex solutions. And so bear with me while we do this. Again, it's in the standard form. What we want to do first is move the constant to the other side. You can actually do this either way. You can either divide by a first and then move the constant, or you can move the constant and then divide by a. For whatever reason, I like to move the constant first and then divide by the coefficient of the a term. Divide by a. All right, and now I need to take the b term divided by 2, all right, the b coefficient, so negative 8/3, divided by 2 would be negative 8/6, which simplifies as negative 4/3, squared to both sides. I'll write that on a new line. Okay, now we will write this on the left-hand side as a perfect square. And over here, let's use our calculator, our handy dandies. We obviously know how to square fractions, but it is never a bad idea to just let the calculator do the quote-unquote difficult work for us. And so I believe this is going to be negative 32/9, but let me just calculate that for us. Yeah, negative 32 over 9. All right, now when we take our square root, you can tell already that we've got a negative numerator or a negative fraction here. So when I take the square root, I'm going to have an imaginary component. The square root of negative 32 over 9 is going to simplify to be 4i radical 2 divided by 3. Now we just need to add 4/3 on both sides. Again, these fractions have a common denominator, 3, so we can combine those and make it one term. And that gives us our complex solution. 4 plus 4i radical 2 over 3 and 4 minus 4i radical 2 over 3. I hope this was helpful. Enjoy.